Mechanics. Problem. Bead on a vertical rod. A bead of mass m can slide along vertical rod fixed on the floor. The friction force of the bead on the rod F is constant and less than the bead's gravity mg. The bead began to slide along the rod from the initial height h. The impact of the bead on the floor is absolutely elastic. After what time t final will the bead stop moving? First of all, we can emphasize here that we have a series of motions of this bead, and probably this series could be some kind of converged ray, and probably it could be geometric progression ray. So let's try to prove this. So first we can use work energy theorem for solving how to count what is the next height this bead will reach after the total travel down and up from next height. Let's say we have height hi, and we need to count what is the next height hi plus 1. So we can write this equation using work energy theorem. We have initial potential energy mghi equal final potential energy mghi plus 1 plus work done by force of friction, which is force of friction multiplied by total distance, which is hi plus 1. From this formula we can count what is the next height. That will be this expression. We see that we have for heights we have a geometric progression with the coefficient this one. And the same thing we can expect about time. Let's count time for each travel. For that we need to count total time when bead going down and the time when bead going up. So for time going down we have this formula. We have height equal 1/2 acceleration multiplied by time square. In our case acceleration is not free fall acceleration because we have force of friction, which is work against motion, and acceleration equal g minus force of friction divided by mass. And from this formula we immediately can count what is time for motion down. It will be this one. The next thing is to count what is the time for motion up to height hi plus 1. Here we have this expression. Now force of friction works against motion in the same direction as gravity. So we have total acceleration or deceleration in our case. That's a g plus force of friction divided by mass. And we have this expression similar to this expression. And from here we can find time. So totally we have time same as for this previous expression, but with a new acceleration. And also we know what is height hi plus 1. That was this one. When we insert this expression in this formula, we will get this one. And after calculating what is total time to travel ta1 plus tai2, that will be this one. After we add this expression to this expression, we will get this expression. And we see that time to travel it's proportional to square root from height. So yeah, that's correct. Now we can create a geometric progression, because now we can express our next height through previous height this way. So we have heights created by square roots. They again have a geometric progression, and when we insert this height to this ti, we will get the geometric progression with a calculatable coefficient. Let's count this coefficient. We can count this infinite row, where we have a zero member, first member, etc. That will have this expression. So we have this is main coefficient, this is zero member, this is first member, so that will be our coefficient. And finally we have this expression after counting the geometric progression series. That's the final result.